Allah, who will be joining us later. Who will be joining us later to discuss some of the solar installation problems. And the next slide, please. So, like I said, my name is Babatunde Orimiduba, the Business and Development Executive. And Allah will be joining us later to discuss the problems associated with the solar installation in Nigeria, as we all know. And then this is the Genesis Technologies. We're into sales. We're into sales of solar components like batteries, inverters, starting from the 1.2 kVA to about 15 kVA. We also have lithium batteries, 5 kilowatts, 10 kilowatts, and 15 kilowatts power. Then we have solar panels ranging from 480 watt rather. We have 480 watt, which is the Jinko panels. We have the 590 watt, which is also Jinko panels. We have 585 watt, also Jinko panels. And also, we have Canadian solar panels. And partnership with also AstraZeneca. So we have the 575 watt and the 580 watt. And we are into installation for home appliances for home use and industrial. Hello. Hello. Can you mute the microphone, please? And we have an installation for home use, for offices, and also for industrial solutions. And part of them, which Genesis have all done for WhatsApp and Petrocam. All these projects are visible, and also for Lubro, which was commissioned recently. Then we are also into the academy, training of students for solar installation, equipping them with the rudiments associated with the solar installation and all that. And then this present cohort is ongoing, which will be coming to an end in the next 1 or 2 weeks from now. And also the next cohorts, which coming up in July, August this year. And the location for the training is in the Petrocam head office at VI. So without much ado, we'll be inviting our facilitator, which is Mr. Ola, to join us and discuss some of the troubleshooting common solar installation problems.
Yes, thank you very much, everyone. Good morning, everyone. Babatunde, I think I should just share my my screen. Just give me a cue.
Can we all mute the microphone, please? For those who are not muting their microphones, please mute, please.
Can you all see my screen? Okay,
Yes, sir.
so yes, my name is Ola, and for the next 45 minutes or so, I'll be taking you through the troubleshooting steps of common solar installation problems. As you know, for both, and this is applicable for both residential solutions, commercial solutions. And on this, for this discussion, we would have a general introduction where we discuss what are the expectations of what we give in terms of solutions, the system components overview, common installation problems, troubleshooting steps. Then we'll look at five common solar problems that are peculiar to the solutions that we give every time. Then best practice and preventive tips. Then after then we can take questions and also give answers to the questions. So yeah, why do we really need to know this? Just as you know, it's important for us to have a very reliable solutions for our clients. Apart from the fact that that is what they pay for, or apart from the fact that that is what you desire as an alternative solutions to the erratic power supply that we currently have in Nigeria, it is essential that whatever we are providing, the solutions we are providing for our clients is stable, is reliable. But if even as said, there are still problems that comes up because you are dealing with electrical components, you are dealing with electronic devices. Problems are bound to happen. You have faults, you have complaints from your clients, and part of the steps that is necessary, it is necessary that as a solution provider, as an installer, you're able to troubleshoot what the problem is and deliver solutions for your clients. As we all know, poor installations, if you have poor installations, you have frequent shutdowns, you have frequent calls from your clients, which is not a good thing. You have downtime, and also it's waste of money because clients that have paid heavily for these solutions want to really have a reliable solution. So the troubleshooting to this key problem is a key to maintaining system performance and customer satisfaction, and also safety as well. So as we know, major key components in a solar system, you are talking about the solar panel, the inverters, the battery bank, charge controller, monitoring systems, and all. And these components can fail, or they can come up with any errors or malfunction. So just look at this system. Each of this system has this of these device as a system where the basic concept of troubleshooting is where you have a system, then your input to the system, and your outputs. That's the fundamental of troubleshooting. You have your system, in this case, might be the solar panel or the inverter. You have the input to the system, then you have the outputs from the system. For example, the solar panel, if a solar panel is not functioning well, you want to see that as a system, then there are inputs that are expected to go into the solar panel for it to generate the output. So the input here, you are talking about the solar being exposed to enough sunlight. the total surface area of the solar panel is well covered and well exposed. Then from the output, based on the specification of the solar panel, you know from your measurements what the output is supposed to give you. So that's the basic and fundamental way to troubleshoot a system. Same way with inverter, just take it like that. What the input of the system should be, what the input of the inverter should be. In this case, you might have grid. If it's an hybrid system, you might have the PV into the system. Then you have the battery, which is also an input and also an output. Then from the inverter, what your expectations are for the inverter to give you. If it's a 5 kVA capacity, then you're expecting that the inverter should be able to deliver to the maximum of 5 kVA. You understand? So these are the basis. If you can identify these three components, your system, in which the system is the whole operation is passing through, the input to the system, then what the output is as basic as that. Then every other thing build on these things. When you can look at it as a whole, as a complete system. If you have a solar system, a complete solar system, and you know what the expectations are. Okay, I have these solar panels, I have the battery capacity. I am expecting the system to be able to this capacity of my load for this specific time. That is the output. And you can also look at it from the concept of individual components, which is what we'll be looking at in the next few slides. Now, common issues that you see in installations, wiring and connection issues, incorrect solar system sizing or configuration, battery management, minimize this, battery management, mismanagement of faulty state of charge calibration, improper grounding, environmental and weather interference, firmware and communications error. So I'll take this one after the other. For wiring, circuit breakers, connection errors, what are the signs that you know there is a problem? When you have no output, inconsistent performance, tripping breakers. Just as I've explained, to troubleshoot systems like this, for wiring problem, just look at it. What is coming into the system, which is if it's a battery cable now, you are expected that maybe you set 20 amps on your inverter and it's supposed to deliver 20 amps to your battery bank. Your input to that cable, the battery cable, is 20 amps, and you are expected to have 20 amps at the output. So if perhaps your battery is not charging and you test at the output, you are not getting any voltage or any current at the output, then first thing you need to check your inputs. Are there supply for the inputs for you to get the output from the other end of the cable or the wiring? If you are not getting any outputs, then is it that the cable is not good, maybe breakage within the cable and all? Then you know that okay, okay, there is input from the cable. I can measure my current from the start of the output of the inverter, but I'm not getting anything from the output. Then you know the system is the problem. The wire which is traveling to is the problem. Perhaps you can also have another issue where you put in 20 amps from one end of the cable from the output of the inverter, and on the other hand, maybe you're getting like 12 amps or 9 amps. Then you have a volt current drop along the line, and you want to know what the problem is. In this instance, you want to look at why am I not getting what I should get? Although there are some acceptable range of current and voltage drop along the cable, but not at the tune of having more than 8 amps drop within a cable. So those are ways to troubleshoot. But with that, maybe you now start looking at what's your cable sizing is, because for every cable you have the cable gauge and the amperage that is set for each cable gauge size. So if you are not using the right size of cable, then there will be losses along the way because you are using the wrong cable size. Then those are troubleshooting steps that I do. That is just the basic concept for you to look at how to troubleshoot individual systems. Same thing with breakers. You want to check for the polarity. Have you done the right thing in connection?
This time?
Then verify the torque and tightening. As simple as that,
Where
that
would
would
you?
be a
Oliver,
problem.
where would
If
you?
you connect the battery and maybe the terminal is not well tightened, or an inverter, you terminate a load cable and the cable is not well tightened to the terminal, you might have no output or partial contact that the output is going off and going on, things like that. And um, you also can use multimeter for continuity test so that you check from one end to one end, is there flow of currents, what you're expecting from this point to this other point. That way you are able to troubleshoot problems with wiring, circuit breakers, or connection problems. For inverter sizing and configuration, what are the symptoms? What will symptoms you see? Frequent shutdowns. You see some inverter will go on overload, short circuits, error codes. Troubleshooting steps. Look at the inputs. Look at your outputs. Are you feeding in? Are you getting what you need to get in from your inputs? Are you getting what is expected based on your sizing at the output? So for frequent shutdowns, so many things can be responsible for that. Overload. And the best way to troubleshoot overload is sometimes you check your the, most of the smart inverters these days will tell you this is an overload, there's an overload, or show you some error codes or short circuits. In the case of short circuits, you just see that the inverter is tripping off frequently. You will power up again and trip off again. So best way to troubleshoot systems like this is to first isolate the input and the output. Try to run the inverter on battery only and see if after disconnecting the input and the output, the inverter is able to run seamlessly for maybe 5 minutes. If it does, then you start putting on your inputs one by one. You put on your PV, no trips. You put on your grid, no trips. Then you connect your load. If you connect your load, there will probably be a shutdown again because that's where the short circuit is causing a shutdown. And how to deal with that is you turn off turn off the output to the inverter first, since we've been able to identify the problem. Then look around the house, look around the load connected to the inverter to see which of the load is causing the short circuit. Sometimes might just be a bulb, all this energy saving bulb going bad. That's what we experience most of the time. You see, maybe all this energy saving bulb going bad, and the elements in the bulb are shorted. So that period of time, it keeps tripping because there's a short circuit in one of the loads. And the best way to deal with this, if you can identify the load, you deal with it, you isolate it, you remove it. If not, most times if clients call like that and they can't find what is causing the short circuit, we tell them to run the system on generator, to run their load on generator for some time. During that period, the load that is going bad will burn out. So that way it cuts the short circuit cuts off, and you are able to restore your load and reconnect your load. So that's part of the troubleshooting steps you do. Then you recheck your load calculation if you are having overload. What have I recommended? Then what's based on the load, what are the loads that are supposed to be connected to the inverter? Then you match the inverter specification to the system design. Sometimes also, if the firmware on the settings of the inverter is not well done or it's outdated, that can cause systems to shut down intermittently. So sometimes all you need is for you to update the firmware of your inverter. If you cannot do that, you can always take your system back to where you get them. We do that a lot in Genex. So firmware update for, the way technology moves these days. The components, the design, the software, the updates, they improve almost every now and then. So sometimes there is need for you to update firmware frequently. So for battery mismanagement, what are the symptoms you see? Rapid discharge, no charging or overcharging, and sulfation. How to troubleshoot this? Thank you. So checking BMS status, look at what the status of the battery is, then also balancing of cells. Then reconfigure your state of charge settings, inspect terminals. Those are the ways to check. Also, you can also check the battery temperature as well, so that you know what's the problem is. Then you have the grounding issue, the grounding and earthing issue as well. What your systems will be, there will be system noise. Maybe the inverter system is humming, or when you touch the system, you get electric shock, or perhaps when you touch any electrical device in the house, like the refrigerator, the cooker, you get electric shock. And how to troubleshoot that? You test ground resistance, you take verified bond between equipment, adjust good sync between your inverter systems and your equipment. Then check for neutral to ground faults to see if there is any leakage. Then you have environmental factors as well. What they do is they reduce performance of the system. That's component overheating. In the case of dust, in the case of hot weather, these periods For example, during the Harmattan season, that's when you hear most clients say, "Oh, this system is not lasting as it used to be. We shut down before daybreak." And these are because of the environmental factors. You have in this instance, what you do is inspect for shading and dirt. You check the solar panels if there are dirt covers, if there are shadings, if there are sometimes you have dirt leaves on the solar panels that needs to be cleaned. They check the ambient temperature as well. If you know for solar panel now, what solar needs is the sun intensity, daylight, I mean. So they also want to have the daylight so that they can generate. But when it becomes hot, then it actually reduces the efficiency and the generation they get. You want to make sure that the installation, there is aeration underneath the panels. If it's the equipment in the power room, it's where and the ambient temperature and where the installed is good. Then you ensure proper ventilation so that the system can work better. So we've talked about individual components and the problems that we face with them. So, like I said, these are the things that you see in a full solar system: the solar panels, the inverters, the batteries, the cabling. These systems will come together, and when you have a full system, a part might not be doing its own job that will be causing the problem for you to troubleshoot. So it's still the same basic concepts. What is the inputs? What is your output? If you know what your output is and you know what your input is, then you know where to look at. So they are all just interconnected together. The solar panel is doing its own job, the inverter is doing its own job, the battery is doing its own job, but they are all working together to achieve this. So bringing all those components together, let's look at the 5 common problems you see for a residential solar system. And the case one we're looking at is the inverter system not turning on. Possible cause: you are not getting power supply, your system is shutting down, damaged inverter system, loose connections in the wiring, battery or grid failure. You can see that these are individual components of what we've talked about in as regards components or device in a whole system. How do you troubleshoot this? First, if a system is not powering on, don't jump to the hardest parts. I see people do this a lot, and it wastes time, it wastes money, and what you think is cannot be might just be the solution to the problem. As simple as it is, first check the power switch. Is the inverter on? Are those breakers that are supposed to be on, are they on? Before you start bringing down all the installations, you check the simple things first. Is the inverter powered on? You can never say someone can just go there and turn it off. It happens. It happens sometimes. Client calls and say, "Oh, the inverter is not coming on. What happened?" And you just realize that the inverter switch is off. Who offed it? They don't know. But it happens. But if you are not careful and you start uninstalling, checking what's the name, cable trays, pulling out, measuring and all. And at the end of the day, you spend 3 hours looking for nothing just to see that it's just the inverter switch that is not on. It happens. I've seen it happen. So then ensure the battery is charged. If it's a battery connected inverter system, if the inverter is not getting the battery voltage needed to start up, it's not going to start up. So want to be sure that the battery is charged, then check for loose wires, reconnect them securely. Might just be time. Sometimes terminals terminals are not well tightened, cause frequent, like an installation done where one part of the battery is of the battery terminal is not well tightened. Battery that is supposed to last like maybe 8 hours, 10 hours was now doing 2 hours and shutting down because it's not saying it's saying it as a partial contact. So those are the things that can cause things like that. And because it's not seeing the enough voltage, then the system might not start up. So look for that. Then if it's grid connected, verify that your home power supply is working. But first thing first, like I said, check your power switch, check your breakers. Those can save you a lot of time. I know, but there was a time I was doing when I did my CWES. I did it in one a company in Ikeja then, and I was placed with they do wiring. They produce wiring, and I was placed with the electrician there to follow them, and they called just like maybe like 10 minutes to closing period. They called them that a part of the machine shut down. We got there and they started troubleshooting. 1 hour into the troubleshooting, they've opened the machine, did everything, just to realize that the main problem is the sockets where the power it's connected to the power. That was where the fuse was blown. And wasted time, wasted so you don't want to be caught doing that because it's so annoying. You're wasting money, you're wasting your time as well. Follow the due process. Those don't jump into finding what is not lost. Take it from the follow the due process and take it from the simplest path to and that way if you see that you're not missing out on anything. Case number 2, inverter output shutting down frequently. Like I discussed, sometimes it's caused by overload, out or output derating. That output derating sometimes, like on Genex inverter, you have error 10, which is output derating when your input voltage is very lower than the acceptable input voltage. Then because it's passing the same to the output, that's what you're going to get at the output too. So it gives that error code like that error warning. So then short circuit from the low solar output, internal that's the internal inverter malfunction. So they have to troubleshoot it like I explained. First, isolate the inverter and let it run on battery only. Isolate the input and the output. I presume that you use breakers for your input and output, so it's that way you don't have to start in. Isolate the input, isolate the outputs, run the system only on battery. and restart the inverter and see if it runs normally, if it's bringing an output. If you're able to do that, first you know that there is nothing wrong with the inverter and the system. So you bring in your inputs, you bring in your grid. If nothing happens, then you start checking the overload parts. The load connected, is it as recommended when the installation was done? Then check for bad appliances. Like I said, even a bulb can cause problems. So you want to check for whatever is causing the short circuits. Then check power supply voltage too. Then sometimes you just have to do hard resets. Resets all and there is a procedure to this to shut down your systems and bring your system back on. Case number 3, system shut down within short period of usage. So your client is complaining that system just shut down. Just use it for 1 hour, 2 hours, it's shutting down. Maybe because of low battery, low energy generation, or wrong system sizing. So how do you troubleshoot for this? You check your battery state of charge. Is the battery well charged? Also, you check for your PV generation. Are there shading? Are there debts? Are there cloud cover also? Because if your solar is not seeing enough sunlight, then you have low generation at the output. So then thermal is it building up within your solar system? Then connection, your MC4 connectors and all, cabling down to your combiner box. Are they well done? Then confirm the sizing. Is the sizing well done? When you install the system and the load connected to the system, is this still as is recommended? If your load has changed, then the system needs to be reevaluated. You need to resize your system. That means your load is changing. Either you let your clients know that the load has changed, they need to maintain the agreed load, or you call for, you let your clients know there is need for reevaluation of the system and resizing of the system or an upgrade. So this way you're able to resize based on the load that is connected to the system. Then what about the grid availability? Check. Because if you have built an hybrid system, which means that grid will be in support for you to have a particular expectation in terms of power delivery within some hours, then you want to be sure that you are getting, if you've considered like maybe 4 hours into 4 hours into the in the design, then you want to be sure that you have that you are getting 4 hours from grid into the system every day. So then case number 4, battery frequent drain. So possible cause: undercharge, overcharging, fast charging. That can cause suffocation as well. Poor aeration, elevated room temperature, system overload. Then the troubleshooting steps is you have to measure what your charging currents are to the battery, then what your discharge current and voltage are also. Then check the load running on the battery bank. Are you fast charging or are you fast discharging? Then the battery management settings, are you setting the right configuration for your battery based on the manufacturer's recommendation? Then room Temperature is very important too. You need to keep an ambient room temperature for your system to last long and work efficiently. Then the case number 5, this is the this frequent system damage. This is, I know sometimes this is the hardest part, where you have a system installed and you have the occurrence of damage at that location almost every time. And for a peculiar situation like this, requires more work because this is not irregular. You've installed one, maybe it might be inverter, it might be battery, and what you realize is that it goes bad, you replace it, it goes bad again, then you have to do more than what you have been doing in terms of troubleshooting. Then first thing you want to do is perform full energy audits, inspect all components, the PV, the inverters, the battery cables, breakers, charge controllers. You have to do a thorough investigation. Then check installation quality. Have you used the right cable sizing? Are there loose connections, corrosion, or poor cable management? Poor cable management can be a headache because um, I've seen an installation without color coding where you have all the the earthing, the power cable, the load cable, the neutral, everything were used. A red cable was used for all. So there is no way you want to know which one is the, and that's an headache already. Poor cable management. Then you review your load analysis, check for inductive loads, which most times they are the culprits here. Check for inductive loads, the pumps, the ACs that causes surges or power quality issue. They sometimes they send this transient power that causes problem feedbacks to your solar system. Check if load exceeds system capacity. Then analyze environmental condition. Are there extreme heats in your powerhouse, humidity, flooding, dust? Sometimes, from my experience, dust in a location can cause this, especially an inverter, to go bad frequently because um, the boards in the inverter they are covered with dust every time, and they cause short circuit on the board and they go bad. So as little as dust can cause damage to your equipment, then ensure proper ventilation for inverter and batteries. Then you also need to evaluate electrical protections. Are there such protection devices, the XPDs, correctly rated circuit breakers, lightning protections, good earthing? Frequent damage may be due to lightning strikes, voltage surge, and fault grounding. So you want to be sure that
Very timid. Very, very timid.
you have the right protection for your system. Then other steps you can take. There, if you are using a smart inverter, you can check the inverter or you are using a lithium battery, BMS logs and events. So this inverters or batteries stores the events that leads to a damage or leads to a fault on a system. So they are recorded internally. You want to pull that out to know what has happened that caused the damage. Then the other thing is you want to interview the user. This is a method that is well used and has been efficient for the physicians, your doctors. For them to diagnose you, they want you to tell them everything about what you've done, what happened, how you've lived your life so that they're able to correctly diagnose you. And from this discussion, they're able to know what the problem is, what you did that led to that. So in this case too, you ask about your usage, did you use it pattern? How have they been using the system? What happened before the damage? Are there frequent manual overrides? Say there is battery warning now and they override it, or maybe there is a short circuit trip off and they forced the breaker to go back on. So you want to ask that question: are there new appliances added, so that you know where to look at? When you ask these questions, you're able to directly look at you're able to deduce and diagnose, okay, this might be the problem if this happened before the damage. So in conclusion, what I would advise in terms of preventive tips is to emphasize proactive system checks, encourage system maintenance with your clients for your systems, then educate your clients on basic troubleshooting. This is very, very, very important, because if your clients don't know how to operate, then there is bound to be problems. They use it just like they are using their NEPA grid and all like that. And you don't, for you to be able to sleep at night, just give them the lecture they need. Because if give them all the knowledge your clients need to troubleshoot. Just the basic system hard reset, basic system restarts. If there are these codes, common codes that you see, if there are this code, you can do this. And if they know, just if they know they are able to do that, and you know that when they are calling you for serious problems which you come in for, but not that maybe a breaker trip and they tell you to come. When you get there, when for complaints like that, when they tell you to come, you are going to spend money to go to the site, but I doubt if the client is going to give you money just when you get there and see that, oh, it's just one breaker that is on off. So educate your clients. It's very, very important. Educate your clients. I know most times when installation is done, it finishes late at night and you are just rushing home. You can't, or maybe when you are done with the installation, the client is not at home and you just left and no. But take time to educate your client, because that saves a lot of problem. It protects your client's investment, and also it gives you some peace of mind as well. Highlight the value of post-installation support. Let them know that if they have any problem, they can always call you, And number 4, take advantage of your unpaid personal assistant. You can ask, like we are in the world of AI now. You can ask all these AI to any question, and they will be able to guide you through what you can do if there are certain problems like this. Take advantage of it. Please don't be left out, because the way these things are going, they are taking up so many roles, and you don't want to be left behind. It saves so many headache, even if you don't know. It's different. It's different from what we used to have. When you have a problem and you type it to Google and you have to search through a bunch of links for you to be able to get the answer. If you have the likes of ChatGPT, the Microsoft AI tool as well, they are free open source tool that you can download and all. Put in your question. If you are using the right prompt, you get the right answer, and they will be able to save you a lot of time and a lot of headache. At least, even if you're not getting what you want, it gives you a point to start, which is the most important thing. But I can tell you for free that these things have the responses have improved a lot. The responses have improved a lot in terms of the quality of response you get from this AI now. Because there is continuous training on all these AI tools. So take advantage of it. If you have problems, put it in, and it will give you possible suggestions to what you can do. Just do it like you're talking to your friend. If it's not giving you what you need, keep asking, and definitely it's going to tell you show you more light to how to start your troubleshooting. That would be all from me. Thank you very much for listening. So we can take for the next 5 or 10 minutes, we can take questions. Thank you.
Mr. Ola. Thank you very much, Mr. Ola, for that expository lecture. So we are now in the section of questions. Do we have any questions? Any question? Yeah, you can type your questions in the chat box, and then we'll attend to them. Or you raise your hand if you have any question. Hello.
Okay, I'm saying any reason for fan failure? Yeah, fan failure for, I guess, for the inverter. One, it could be that the system is not the fan is working tirelessly, which is also as a result of poor aeration. So there are no enough air going through the system. So the fan has to work tirelessly. If you have your inverter system fan running every time, then that's not a good sign. And sometimes, even when you have fan failure, it could be dust. From my experience, it could be dust because sometimes the fan failure, it's not actually that the fan is bad, but the point of connection on the board of the inverter is bad. So maybe the board controlling the fan, that board is bad. And most times what we see that causes that is the fan, sorry, the dust on the board itself. So yeah, I said for error 10 on Genesis inverter is output derating, where the voltage from your grid is below the acceptable voltage range for the inverter. So in that case, maybe what your voltage is from your grid is maybe 80 volts or maybe 90 or 100 volts. If it's below the acceptable range for the inverter, it passes that same input to the output. So that way you are getting same output so the inverter will beep. I think for Genex inverter, it beeps like twice. Pum, pum. So intermittently it beeps like that, giving you that warning that there is an output derating in terms of voltage. And the best way to solve that is you maybe use a voltage regulator at your input to get your voltage to the level accepted by the inverter.
Someone asked, what's the highest kilowatt inverter we have? Well, we have the 15 kilowatt, which is the GNS inverter. We have a 15 kilowatt. Then another question is what causes bus voltage too high error in forward inverters.
I think that's when error should be fixed also. But it's an internal. I can't really place because it's an internal issue. The team that is into repairs will be able to speak to this, but I know it's an internal which is something that has to be analyzed, but there is a cause to it, which anything can cause an internal failure like the F09, F06. So anything can cause that. Please, what's the effect of using AC cable instead of DC cable for PV? There, I mean, it's you can't use AC cable. AC cable most times they are a single core hardcore cable. So and DC cable they carry more of currents in terms of DC. So DC cable, you want to use DC cable for DC current or DC voltage. So it's not advisable. And if you look at DC cables, most DC cables they have multi-strands. They have multi-strands in it for moving current and cable through the setup. So is it ideal to connect or take your PV18 and input 18 from same source? If not, what the possible effects to it? Yeah, most times what we do is for PV18, we advise that you have a separate heating system for your PV because your PV is out there exposed to thunder strikes and all. So, and you want to, if there are strikes from your PV, you don't want it to come to the house. So it's advisable that you have your PV connected to a separate heating done for your PV specifically. While for your appliances, for your home appliances and all, you have its own separate heating.
And another question.
Short circuit in inverter and battery beeping. I talked about that during the lecture. Short circuits most times comes from the load. If it's not a damage within the inverter, which isn't most case, it's a short circuit between short circuit in your load. And from my experience, most times is maybe a board going bad. Sorry, a bulb going bad. The LED bulbs do not do that, but all these energy saving bulbs, all these toxin and filament bulbs, they do that. They causes that. So if they are going back, they are shorted inside, and when they short, it trips off the inverter or the cable, the breaker connected to the system. So what you need to do is to first isolate your inverter, let it run on battery, try and see if when you restart the system, there is output from the inverter. Then when you confirm that, then you start putting back the input and the output. You connect your grid, connect your PV. If you have no trip off, then you connect your load. If you connect your load, then the inverter should trip off again. Then that way, you know that is the problem. Then you isolate your load, then check within the house to see if there are short circuits. And the best way to deal with that, if you can identify that, is to run all your loads on generator so that whatever is going back and go bad finally can cut finally so that you can stop the short circuits. And that way you should be able to address that. So can you use hybrid inverter without a battery in the daytime? Yes. Yeah, if it's without batteries, if solar is present with your inverter, it will power your load. It's going to, but mind you are not using battery, which means that whatever your generation is should always be higher than your load. So if your load is 100 watts, make sure that your energy generation is over 100 watts, because sun goes up and down and you have your sun intensity that fluctuates, so you cannot control that. But at any point, you want to be able to deliver at least 100 amps to the load. At any point when the load is higher than your generation, the system is going to shut down, which is not a good design. Okay. I had two situations recently: solar charging on 12 volts, 45 amps, and four 300 pulley solar panels. But the current entry the battery is now up to 1 amps. What could be the cost? 12 volts, 24, 40, okay. And four 300 watt, but the current thing. So for a problem like this, when you are not getting your outputs, what your expectation is on the output. Like I said, there is 3 basic things to troubleshooting: your inputs going through a system, then your outputs. Your output is not working, so 2 things that you need to check is the system itself and your inputs. What are your inputs? So for your inputs now, which is the solar system, you want to see that first, is your solar system producing outputs? First, you need to check, is your solar system producing outputs? If you can measure the desired output from your solar system, then you know that part is solved. Then from there, from your solar panel, you have your cable running through the charge controller. Then you want to test from your output of the solar panel, are you getting the same the expected output on your charge controller? If you are getting that, then you go further again and check your connection between your charge controller to your battery. But you need to check these points. If you miss any point, then but first you need to know what you are expecting. You need to know what you are expecting from the output of your system. From your solar panel now, you need to know the current and the voltage you are expecting. If you are not getting that, then that's where the problem is. That way you are able to, you check from the start of your system down to where you are getting the 1 amps. But definitely there is a problem somewhere. Inverter is not turning on with battery, but can turn on with panel, with FO8. I can't remember what the FO8 is offhand now, but so I can't really. Inverter is not turning on, but with battery, but can turn on with panel. Then first you need to check if your battery state of charge is right, because if it's so, what that means is that it's saying voltage, it's saying power from your solar, which is supporting the startup. So you need to check your battery bank. Is the voltage right? Is it charging? Is the battery charging? I want to be sure that the battery is receiving enough charging current to boost up the state of charge of the battery. I need more explanation on KVA and in terms of difference. Okay. like, okay, so kilowatts. Kilowatt is the usable part of your inverter. kVA is a combination of the usable parts and the one you cannot use. So for instance, if you have a 5 kVA system, now, and let's say the power factor is 0.8, which is so you can, in that case, 0.8 of 5 kilowatts, 5 kVA is 4 kilowatts. 4 kilowatts is what you can actually get out of that inverter. That's the usable part of the inverter you can consume, the part that you can use. You see the other 1 kilowatts you can't get it because those are the losses within the inverter. That's the conversion. So you have like 20% loss in terms of conversion because your power factor of the inverter, it's always stated in the specification sheet. Power factor of the inverter is 0.8. For most inverters, like Genex inverters now, the power factor is 1. So your 5 kilowatts, your 5 kVA system is going to be 5 kilowatts, which means that if you run your usable kilowatts, your usable capacity of the inverter is 5 kilowatts. That's the difference between kVA and kilowatts. kVA includes part that you can't use plus usable. Kilowatts is the part that you can use fully. So if you have a 4 kilowatt load now, you can run it on 5 kVA system because that's the capacity. But if you have a 5 kilowatt load, it can run on 5 kVA inverter. An inverter with 1 power factor have 5 kilowatt load. You can run it on 5 kilowatt inverter. That's the difference. What could be the reason for a 5 kV that usually powers the pumping machine now showing overload error? Could at the same time load after about a year? You may need to check and measure the load. At times, this inductive loads, as they age over time, the power consumption increases. So you want to check if the rating on the load is still the same, or if it's
out there. Where
so, look at the load. Most times your inverter capacity does not change, but I think I believe that the culprit will be on the load here. So look at the load and measure the consumption on when connected to the system.
Totalogic, Mr. Ala, can we have Totalogic and
Okay.
Totalogic Technologies question?
Mm.
Please unmute your mic and ask your question. Totalogic. Hello, Totalogic. Unmute and ask your question. Okay, Nero, can you unmute and ask your question as well? Hello. Hello. Nero. Okay, we can go on with the questions.
Okay. So is it advisable to
Good morning.
Good morning.
Yes, sir. So my question is, when you are talking about gauge of cable, I know if it is too low, you maybe have lost it. But if it's iron, does it
It's when you are trying to choose the cable gauge,
Yes.
two things that you need to put into consideration is the current and voltage flowing through the system. Most importantly is the current. Then the length of or the distance where the cable is going to travel, because as the distance increases, then you have a voltage drop or a current drop as you have losses along the way. So you want to be sure that you have the gauge that is enough to carry what your input is down to your output without loss or with very minimal loss, but it will be good. So if you have higher cable gauge, it's okay, but then you have to keep your cost down. If you are quoting, your cost has to be competitive. So you need to choose the right sizing. It's okay if it's larger, but it shouldn't be an overkill.
Okay. Okay, thank you, sir.
Is
Mr.
it
Logic, can we have the question as well?
Yes, I got it, sir.
So
Mr. Logic, can we have your question? Olaolu Ajayi, are you there? Can we have your question as well? If Mr. Logic is not ready. Hello. Okay, we can go with the remaining questions.
okay, so is it advisable to power pumping
Hello,
machine?
good morning. Can you hear me, please?
Yes.
Good morning. Go ahead, sir.
I don't know if you can hear me.
Yeah, we can hear you. Go ahead. You can go ahead, Mr. Laulu.
Hello, sir. I don't know if you can hear me. Good morning.
Yeah, good
We can
morning.
hear you. Go ahead.
Okay. My question is this. I have a system whereby yes, there's a panel, inverter, and the batteries. But all of a sudden, we notice the system doesn't last long. So I think they called an engineer, and engineer now recommended another set of solar arrays with a different charge controller, but to be charging the same battery. So my question now is there any side effect of having two separate solar arrays charging the same battery? Is there any side effects on that? Is it that it will be overcharged, or is it a good practice? That is the question I want to ask. Thank you.
Okay, so like I said, first and first, you need to know what your expectations are in terms of point to point. For example, if I have a string of 12 volt 200 amp hour battery now, I'm expecting that if I'm going to who is doing this? Okay. If I'm going to charge the battery, I want to have a 20 amps charging the battery. You should know what your expectations are. So if irrespective of whatever array you put out there, whether two separate strings or not, am I getting 20 amps to my battery bank? That's the most important question. So if at the end of the day, whatever it is that you put up there, you only set 20 amps to deliver to your battery, then it's done, no problem. But you have to do this for every part of your system. You have to do this with you have to do this for every component of your system. For your solar system, you want to know, I need that's where your sizing comes into play. If you've done the right sizing, you have considered what's your load will take, what your charging your battery will take, and that would guide you to determine what your solar array is going to be. So if it's not charging very well, that means that the solar array is not well sized, which will affect the charging of the battery. So the most important thing here is to know what your output is. What is the expected output? In this case, in the scenario I'm talking about, if I have a one kilowatt connected to my inverter and I have a 4 string of battery, so I must generate 1 kilowatt for my load at least, then generate 20 amps also to charge my battery. So if you combine the two together, that would give you an insight into what your solar sizing should be. So if your solar sizing is not up to that, then you have energy deficits. And when you have energy deficit in a system, your system will continue to shut down. Does that answer your question?
Yes, thank you.
So is it advisable to power pump machine with inverters, taking into consideration the starting torque? Yeah, you can power anything with inverter if you've done your sizing very well. If you have considered the specification of the inverter you are using, we've considered the power factor and the starting current of the starting current of your load of your pumping machine and the load consumption of the pumping machine. If all this is considered when you are choosing and sizing for your inverter, you shouldn't have any problem. Inverter can power anything as long as the sizing is done rightly. What's the difference between power factor and efficiency of an inverter? Truth being told, power factor is what we use the most in when it comes to sizing, when it comes to solar. It's more important, but because that is what tells you what part of a system you can actually use. The efficiency of inverter is still a bit because it's not that clear what the meaning of that is. I haven't checked it, but because we have not really have means to use that data most times, but for power factor, it's a crucial part of um, your sizing, inverter sizing, and also what parts you think you can actually load. There are some inverters that come with 0.6 power factor, and they will call it 5 kVA. I bought a stabilizer at the point, and that stabilizer was rated, it's a 5 kVA system, but 5 kVA stabilizer was 0.6 power factor, which means that I can't use more than, I think, 3,000 watt out of the 5 kVA. So I can't use more than 3 kilowatt out of the 5. So it is important. The power factor is more important because that tells you what part of the machine you can use. But the efficiency of inverter, I have really
Sir,
not have any reason
you
to.
have already explained it. You have already explained it. Power factor is what determines the efficiency. The power factor is determining the kVA into kilowatts. And that's why you say if you have a 5 kVA inverter and you are now using 4 kilowatts, when you take out the 20%, when the 80% that the kVA is delivering, which is 4,000 kilowatts, That is the efficiency of the inverter, and it is the power factor that determines that efficiency. That's why we say it's almost like the same thing. You have already explained it. Efficient, because
I get it.
inverter is talking about DC to AC, and at the same time, it's doing that work of delivering kilowatt to your load. So what will determine the efficiency is that power factor. It's like the same thing. You have already explained it.
Yeah, I get you. Thank you, Mr. Shina. But I understand from the person that asked the question, because the power factor, like I explained, is to a certain percentage, where on the same data sheet you have efficiency of inverter, which is around maybe 93 to 98 sometimes on some inverter, which is quite different from the power factor. So I know I tried to explain that you can easily interpret the power factor to be efficiency, but so that it's not confusing for people, let's just stick to power factor, because power factor is the most important thing here. I've not even had any reason to use the other data, which is the efficiency of inverter stated on the data sheets. But the power factor is very, very, very important, because that is what determines the part of an inverter you can use. For Gen X inverter, is 1-to-1. It's one power factor, which means that you can use, if it's 5 kVA, you can use all the 5 kVA. But it's not like that for every inverter. Although technology keeps improving, but for Gen X, the power factor, so the usable part of the Gen X inverter is you can use everything. If it's 5 kilowatts, if it's 5 kVA, you can use every part of it. So when using high voltage inverter, what is the best way to connect to panel? Is it parallel, in series? It all depends on the system configuration and the data sheet of the system you are using. If you are using an inverter and they tell you that, oh, this inverter is a high voltage, can take 450 volts of PV inputs, but cannot take more than maybe 27 amps of 27 amps of input. So you need to look at the panels you are using. If your panel is 13 amps, so which means that you can string your panel up to maybe 450 volts. Then if your panel is 13 amps, if your short circuit current is 13 amps, that means you can have 2 strings on that. 2 strings is going to be 26 amps. So 26 amps, you can have 2 strings on that PV input. So taking that is a function of what the specification of the inverter you are using and the input specification is vis-a-vis the solar panel you are using. I mean, advantage and disadvantage of using series and parallel. Series, if you connect more parallel in series, you have less cost on cable accessories. Like you can have 8 panels, not panels connected in series, where you use just a single 6 mm red and black to take it down to your combiner. It's different from if you are doing four panels or doing 3 panels. That way, the higher your current is, the higher your current your cable gauge has to be. So that is increasing your cost. So if you are doing more in a series as permitted by your inverter, then you will have less cost on cables. What's the rate of THD inverter if it's higher than 3%? Not sure what the THD is. If you can give me the full meaning of that. Does a panel string that is oversized in current affect an inverter, or the inverter just take its required and life? Yes. If the most important when you're sizing your PV input is you don't want to exceed the PV voltage recommended by the inverter manufacturer. Once you are within the range, currents from my experience, even if you are within the voltage range, then the current is more. Just like if the current is more, it's just going to ignore it. Take what the inverter can take and leave the rest. It's just like if you have 1000 watts solar connected to your inverter and you have no load connected to it, if you measure your cable at that point, your PV cable is not going to, you're not going to see any reading until you connect your load. When you connect your load, then it start drawing from the sun, from the solar array. But mind you, it's not going to draw more than the capacity of the rated PV controller in the inverter. So it's just going to take the maximum current it can and leave the rest.
So because of our time, we'll be drawing according to our exposition this morning. We'll be drawing according to that due to time. So I want to appreciate everyone for joining the webinar, and I want to appreciate our moderator, Mr. Ola. Thank you very much for your time. We really appreciate every question raised and the contributions. Thank you very much, sir.
Thank you.
All right, sir. You enjoy the rest of the day, everyone. Thank you.
Bye. Bye, everyone.
Bye. Bye-bye. God bless you. Bye.
All right, thank you.
Bye.
Thank you very much. Bye-bye.
David, bye-bye.